Hello everyone, welcome to the new video. So in this video we are going to talk about deterministic finite automata. So the definition for DFA goes like this. For each state and for each symbol in input alphabet, there is a transition to some state. Let us understand this with an example. So for example, we are having a states as Q0, Q1 and Q2. And we are having our input alphabets as A and B. So here Q0 should have both A and B going to some or the other states, and Q1 should have both A and B, as well as Q2 should also have both A and B. That is, each state should have all the input alphabets whatever are mentioned. That's what is different from DFA to NFA. So let us draw a diagram for this. Let our initial state be Q0 and also our final state. So when Q0 we have Q1 and also Q2. So when Q0 is applied with A, it goes to Q1, and when applied with B, it goes to Q2. And Q1 when applied with A goes to Q2, and when applied with B goes to Q0. And and Q2 when applied with A goes to Q0, and when applied with B goes to Q1. Here if you see all the three states, that is Q0, Q1 and Q2, all the three states are having whatever the alphabet which are mentioned. So this is what DFA is. Let us understand the formal definition of DFA also. So any finite automata will have 5 tuples. Those are M, which is machine, Q, comma, sigma, comma, delta, comma, Q0, comma, F, where Q is a set of all states. So what is our Q here? Q, from the diagram we have 3 states, Q0, Q1 and Q2. So our 3 states are Q0, Q1 and Q2, and sigma, which represents a set of all input alphabets. What are the alphabets which we are using in the diagram here? A and B. And delta is a transition function which maps from Q cross sigma to Q. Next one is Q0, which is our initial state. Our initial state here is Q0, so Q0 itself. And F. F is a set of final states. So we have only one final state in the diagram, that is Q0. So it is also Q0. So these 5 tuples represent the formal definition for this diagram. So let's understand the transition function a bit more. So delta of Q0 comma A, that is when Q0 is applied with A, it goes to Q1. Q0 applied with A goes to Q1. And delta of Q0 comma B, Q0 when applied with B goes to Q2. And delta of Q1 when applied with A, Q1 with A goes to Q2. And delta of Q1 when applied with B, Q1 when applied with B goes to Q0. And delta of Q2 when applied with A, Q2 when applied with A goes to Q0. And delta of Q2 when applied with B goes to Q1. So these are transition functions for this diagram.